Hello and welcome back. So this is a new lecture series on for first and second sem students of VTU, and this will be covering almost everything related to civil subject in the first and second year. So moving right into understanding what mechanics is. So the first question arises is, what is mechanics? So with the example, let me explain what is mechanics. So you can see there is a man who is strong enough and he has a hammer in his hand. This person holding the hammer needs to strike the base of the tower. So this is a game wherein strong man, it is also called as a strong man's game. Now if the force is very high, then the puck rings the bell. If force is less, then the amount of force applied is not good enough to ring the bell. Therefore, I can say that mechanics is a branch of physical science that deals with state of rest or state of motion under the action of different forces. So that is called as mechanics. Now, what is engineering mechanics? Engineering mechanics is the basis of all the mechanical science. This provides the building block for statics, dynamics, strength of materials, and fluid dynamics. Now, we need to understand certain important concepts before going into detail of mechanics. The first one is matter. So, what is matter? Anything or any material that occupies space is called as matter. This matter can be in different states. It can be in solid form, it can be in liquid form, or it can be in a gaseous form. So that is matter, anything that occupies space. The next one is mass. What is mass? It is the amount of matter in an object. The amount of matter in an object. So there is an object. When it is kept on the earth, it has a different weight. But the same object when kept on moon, it will have a different weight. But the mass remains constant. So the amount of matter inside the object is called as mass. The next one is volume. Volume is the amount of space that an object takes up. How do we calculate volume of a rectangle? So, length into width into height. When we multiply these three quantities, we get how much space that object can take up or occupy. So, that is volume. What is state of rest and motion, or we can say state of rest or state of motion? So we see there is a football. It is kept at rest. Object is at rest when the position of the object does not change with respect to the fixed point. So that football is kept at a particular place, and with respect to that particular place, it is not moving anywhere. The position of the object is not changing. So that is why it is called as state of rest. Now, what is state of motion? Motion is said when the position of that particular object changes with respect to fixed point, with respect to any fixed point or a reference point. When there is motion, when some external force is applied. Okay, so that is state of rest and state of motion. Now we'll try and understand what is scalar quantity and a vector quantity. A scalar quantity is that type of a quantity which has only magnitude, that is only magnitude and no direction. But a vector quantity is one where it has both magnitude and direction. So examples for scalar quantities are length, area, volume, speed, etc. And the vector quantities are wherein it has both magnitude and direction. So it is going in this direction. When we say that it is some object of this much mass is going into this direction, then it becomes a vector quantity, such as velocity, acceleration, movement, force, drag, thrust, weight, etc. become vector quantities. The next, we need to understand distance and displacement. So let me take the example wherein there is a red dotted line and there is a straight gray color straight line, wherein a person is moving from A to B, or we'll consider a body moving from A to B. So the total length of the curved path from A to B is called as the distance moved by the body, or it is distance moved from A to B. When a body is moving around the dotted line, that curved path becomes the distance traveled or distance moved. But what is displacement? Displacement is the distance moved by the body from A to B in a straight line. So when we measure along the length of the body moving, that becomes distance, and displacement is directly from A to B, that is a straight line. So distance becomes a scalar quantity, whereas displacement becomes a vector quantity. Yes. The next one is uniform and non-uniform motion. Now, what is uniform motion and non-uniform motion? We might have studied this in your 8th standard. Okay. So, when a body starts, okay, so we consider a car, okay. So, when we start a car, we want to go from our house to our grandma's house or grandparents' house. We start the vehicle, okay. Then at certain speed, say 40 kilometers per hour, you're traveling. Then there is a vehicle which is coming in front of you, so you have to reduce the speed of the vehicle. So you start driving it at 20 kilometers per hour. After some time, again you increase the speed, so that becomes your non-uniform motion. And uniform motion is where the speed of the car remains constant throughout the journey from point A to point B, or from your house to your grandparents' house. So the difference between I hope you all understood the difference between uniform and non-uniform motion. So now let us see the examples. So the motion of the clock, I can say that it is uniform, or the motion of the earth around the sun is uniform in nature. Also, 10 kilometers to 20 kilometers, it is in 5 minutes you reach. From 20 to 30 kilometers in 5 minutes you reach. From 30 to 40 kilometers in 5 minutes you reach. So that also becomes a uniform motion. And non-uniform motion is where the example is from 10 kilometers to 35 kilometers you reach in 10 minutes, wherein the from 35 kilometers to 40 kilometers you reach in 10 minutes. So, and there are different vehicles moving in a crowded place. Once the crowd reduces, you increase the speed. If the crowd increases, then you decrease the speed. So these are the examples of uniform motion and non-uniform motion. Now we will understand what is acceleration and what is retardation. The change in velocity per unit time is called as acceleration, and it is always positive in nature, and the velocity keeps on increasing. But retardation is change in velocity per unit time, but it is in a negative way, or the velocity keeps decreasing, so that is called as retardation. Now what is momentum? Momentum is nothing but how difficult it is to make an object stop. It is a vector quantity, and there is, we'll consider two objects, okay? One is a truck and the other one is the ball. So which will have higher number of momentum, or how difficult it is to make the object stop? Is it easy for the ball to stop, or is it easy for the truck to stop first? Yes, you all are right. It becomes very difficult for the truck to stop because it is having a higher momentum. And whereas the football is easier to stop, that is, momentum is less when compared to the truck. So it becomes easier for the ball to stop. How do we calculate momentum? Momentum is equal to mass into V. V stands for velocity. Yes. So with what speed the particular object is traveling, and what is the mass of the object. So we can define that momentum as quantity of motion of a moving body, and it is denoted by letter P. Now what is inertia? Inertia is the tendency of an object to stay at rest or preserve its state of motion. So when we consider a slide and we keep something at the top of the slide, it continues to remain in the same motion until it reaches the end. So that is called as inertia. The next one is force. What is force? When some external means is applied to an object, that becomes force. So there are different types of forces. One is contact force, the other one is non-contact force. Contact force comes when interaction of two bodies happens. So there is again different types: applied force, spring force, drag force, frictional force, normal force. Then there is non-contact forces which exist. One, that is when there is attraction or repulsion even from a distance. So there is magnetic force, electrical force, or gravitational force. Now we'll understand Newton's law of motion. So the first law states that every body continues to remain in its state of rest or of motion until and unless an external force acts upon it. Now, if I consider a ground and I keep a football on it, it will not move until and unless external force is acting upon it. Either it may be the force exerted by the foot of the person's leg, or the wind acting on the ball. If the wind acts, there is an external force on the body and it starts moving. So it will remain in the state of rest until and unless there is an external force acting upon it. In the second statement, he says that it remains to be in uniform motion. If I consider there is a uniform motion of the ball from point A to point B, if and only if there is an external force against it, then only the ball comes to rest. So that is the Newton's first law. Now Newton's second law states that the rate of change of momentum of a body is directly proportional to the applied force, and it takes place in the direction of force applied. So what I can say that force is directly proportional to rate of change of momentum. So I explain what is momentum. Momentum is nothing but mass into velocity. So rate of change of momentum is equal to mass into rate of change of velocity, which is equal to mass into acceleration. So I can write force is equal to mass into acceleration. So the Newton law says that rate of change of momentum of a body is directly proportional to the applied force, and it takes place in the direction of the force applied. So the third law of motion of Newton states that for every action there is an equal and opposite reaction. Now I consider a swimmer who is swimming, and there is a wall there, and with the help of the foot she exerts the pressure. When she exerts the pressure or force on the wall with the same uh, amount of energy or force, she'll start to move in the other direction. So for every action there is an equal and opposite reaction. So these are the three different Newton's law. Now we'll understand the different branches of mechanics. So basically mechanics consists of solid mechanics and there is fluid mechanics. We'll not understand fluid mechanics for now. We'll concentrate on solid mechanics. So solid mechanics has again two different classifications. One is the rigid body mechanics, the other one is the deformable body of mechanics. I will explain what is rigid body and deformable body. First, a rigid body is one wherein if I consider 2 points in that body, when any external force is applied, the distance between the 2 points does not change. But in deformable body, those 2 points inside a deformable body, when an external force is applied, there is a change in the distance. Example for rigid body is iron, and for deformable body is a rubber. So mechanics of rigid body again is classified into statics and dynamics. Then dynamics is again classified into kinematics and kinetics. We will study these in detail in the upcoming classes. Thank you for your patience listening.